What we see here is something called the furin cleavage site you may have heard of. In the top right, you can see the virus, and on its surface are the spike proteins, the sticky out spike proteins that bind to your cells principally through a receptor called ACE2, as well as other ones. Now, you've probably heard about spike to ACE2 if you've read into literature. What you may not have heard about is the cutting action of two enzymes, protease enzymes, that cleave or cut into those peptide bonds. Firstly, furin, which cuts at the junction between the two subunits of spike protein, S1 and S2. And secondly, an enzyme called TMPRSS2, which cuts at the S2 subunit. Now, the spike protein, which is cleaved by furin, it's expressed abundantly in the respiratory tract, i.e. around your lungs. Now, you think about how we're talking about severe acute respiratory syndrome, the idea of it's a respiratory virus. Now, it has many mechanisms of damage, this virus, and also the vaccine, which is using that spike protein. But what's interesting is, why does this virus have an insert PRRA, so that's, 12 nucleotides, 4 amino acids? It's not present in any other similar virus, even the most similar one, which is a bat coronavirus called RAT-G13. It's missing. And it's there in all the other similar viruses. It's missing. Well, that's a bit odd. And there have been theories. This thing came through an intermediate host. I've heard bats, cats, pangolins. No evidence for any of them. What there is, though, if you go into the BLAST database, which has DNA, RNA sequences, February 2016, Moderna have a 19-length nucleotide, and look at that, codon-optimized polypeptide sequence, and there it is, patented 4 years before any of us heard about SARS-CoV-2 or COVID-19. And what does it include? Oh, imagine my shock. PRRA, furin cleavage site, which enables you to have that infection of the lung cells efficiently. Well, that's very odd, isn't it? It's very strange.